All right, very good evening, one and all. Hope you all can hear me and see me. If you can hear me, please say yes. Please do say yes if you can hear me and see me. All right. Okay, so some people had advantage around today, right? Some people had the advantage around today. Okay, some people have tomorrow. Okay, got it. All right. If you had, please do share some of the questions that you got to us on Edyst. Would love to see from you. What kind of questions you've got? If you could share, that would be cool. All right, somebody's saying the questions are based on trees and graphs. All right, do share with me if you have anything. I'll be happy to discuss at least to see what are the kind of questions and then to discuss them. I'll be happy to do that at least, you know. So that's at least I can show you how to dissect the problem. So if anybody has, I'll just share on team@edyst.com. If you have any particular thing, I can at least show you what you can go for. What is the logic that you can go for probably, right? If you have some questions from today, please send to team@edyst.com or give me the link in the chat. Right, I can definitely look into it right now and suggest the ways. Obviously, we can't really practice it right now, but I can suggest the ways in which you can solve it at least, right? So that's one thing. All right, cool. So any other sort of things that you want, everyone? We'll start the session otherwise, but anything else specifically that you guys would like to discuss? Right. So by advantage around, do you mean HackWithInfy? So what's happened is on InfyTQ has an advantage round. So I'm talking about that actually. I'm talking about that part. There is the chat. Why is the chat not? Yeah, got it. So particle simulation, yes, that we'll discuss today for sure. Okay. It's a very good question. So, all right. So today, what I had in mind was something like this. I believe it's here. No, that's not there. Yeah. I qualified for InfyTQ but did not get any mail regarding advantage round. So I guess I'm not sure. Then at that point, why you've not got. So I can't really say why you got or not got. Today I had planned particle simulation and strong primes, everyone. So yeah, that's one thing. People watching on YouTube, do say hi on the chat on YouTube as well, so that we come to know that you are indeed watching. Somebody said I've sent a question by email. Okay, cool. Let me just check that question. Let me see if my team can just send me that question as well. Okay. So somebody's opened a work. So I'll spend like the starting 10 minutes or so just looking at some question if it has at all it has come. Let me just check that. Right, and then we'll go to the questions that we actually have on the platform, and then we can discuss those also. Alrighty. Others, if you want to send anything, do send to team@edyst.com. You can alternatively drop the link in the chat as well, so that I come to know that you guys have something. Okay, cool. All right. Okay, there's a bunch of messages on YouTube as well. I'll just check those in a bit. Let me just open up. Somebody sent some message. That's what they say. My friend got a variation of knapsack. Yeah. So DP, I'm fairly certain they're going to ask. DP, I am fairly certain, and this particle simulation comes down to that. So I'm fairly certain DP is going to be asked. LCS is asked. Okay, awesome. That's great. Can we discuss minimum pluses problem? So I've already discussed that in one place. We can also discuss, but I already discussed that in a particular place. And got a backtracking one. Superb. That's also great. So minimum pluses is, I've already discussed it earlier. I think the video should be available somewhere with the entire thing. Okay, cool. So I didn't get anything, by the way. Somebody's asking me. Somebody said, but we didn't get anything on email. At least I didn't get anything right now. Um, got it. Okay, you sent to team@theredis.com. Okay, awesome. Got it. Okay, so I've got one thing over here. Just 1 second. No, I still didn't, probably went gone to the spam or something. 1 second. No, I've not got anything over here. 1 minute ago. Okay, yeah, got it. Got it. Yeah. Is it this one a subset of that? You have to give an array of an integers. That one? Okay, got it. Fair enough. All right. Subset of the array is considered valid if the following conditions hold true. Okay, cool. Yikes. The quality is not super great. Yeah, I'm showing you guys also. 1 second. Let me just try to read the question. So I've got it in this kind of a condition, by the way. So 1 second, let me check if it's a showable condition or not. 1 second. No, let me just download it. Yeah, here we go. Okay. And here we go. Send 2 more questions is what you're saying. Okay. Let me see if I've got for the next 1 second. Yeah, so this is one question I've got. Starts here. You're given an array A of size n and m queries. Let me try to zoom in a bit. Yeah, so this is the question that's been given. I wonder if it's viewable by everybody here. Yeah, okay, it seems to be decently viewable. All right. So you're given an array A and you're given an array A of size n and m queries. Each query can be one of the 2 types below. Type 1 query of form 0, index, v, denoting that you will set A index equal to v. The result of this query is always 0. Okay. The query of the form 1, 0, I. The result of this query is AJ such that it follows the below constraint. J minus I is minimum, AJ greater than AI, AJ not equal to AK for all K in 0. I feel like there's something missing over here. Type 2, the query of the form 1, 0, I. The result of the query is AJ such that it follows the below constraints. J minus I is minimum. We need to find AJ greater than AI and AJ not equal to AK for all K in 0 to I see. Okay. But what if there are multiple J's? Oh, J minus I has to be minimum. Got it. Okay. So basically speaking, what they're asking you to do is they're asking you to find over here a J such that AJ is greater than AI, J minus I is minimum, and AJ not equal to AK for all K in 0 to I. So it basically it cannot be on the left side. So it's not on the left side is what we're saying. It has to be on the right side of I, right? Because it cannot be equal to AK, right? That's the idea. So it has to be equal to on the right side. It cannot be any of the numbers on the left side as well. Okay. Just give me 1 second. I think the camera's popped out. Just 1 second. Right. Today we'll go on for a long time, everybody. Don't worry. We have a long session today. Right. Cool. So the idea being, okay, find the XOR of result of all queries. Interesting. So you have to find all the queries and you have to find the XOR. Okay, it is guaranteed that all queries will be of the given types over here. Okay, interesting. Do they have another example? It's the same one. Okay, this is a different question. Got it. So these are the two different questions. Interesting. Let me just think of this. What are some thoughts over here? So basically what you're going to be given is, okay, so you're going to be told that you have to set. So you're given an array of size n and m queries. So first, the type 1 query that you're going to get, the type 1 query that you're going to end up getting is of the form 0, index, v, denoting that you will set a of index is equal to v. The result of this query is always 0. All right, fair enough. So the result is 0, that's fine. And 0 XOR something is anyways that number. So this is not going to, this query specifically is not going to do anything to us. Okay. As usual, my camera's today erroring out. Let me just fix the camera first properly and then resume my train of thought. Just 1 second. All right. So the idea here being that the first query is just going to set a particular number, right? And the second query, what it's going to do is it's going to say it's of the type 1, 0, I. Result of this query is AJ, meaning that this is more of a finding query. It's basically saying that find the number on the right side, the nearest number on the right side. You have to find the nearest number on the right side such that it is greater than AI and it is not equal to any number we have on the left side for all k in 0, I. So basically it should be the first greater element on the right side, and it should be such that it is not equal to any element that I have found on the left side, right? I have to find that and I have to get that number. And once I get that number, I can basically find out. Yeah. And so basically I have to take the XOR of all such numbers, right? Got it. So I have to take an XOR of all such numbers, right? That's the thing. Okay. Some problems were not clearly defined is what people are saying. Yes. That's how it works. That's how HackWithInfy often works. All right. So the question is basically this. So if I understood the question properly, it comes down to something like this. I don't know what to call this question. Somebody's saying it's I'm not sure what the question is, but anyway, Q1 given by someone. Okay. So the idea is basically you're given an array of n numbers. Now it says that n numbers are already there. It's like it's already given that you'll have n numbers completely. Have they given any constraints? So at least in the screenshot that I got, there are no constraints as such. So I can't say for sure that the constraints are there. So that's one thing. Second thing is, so you're given an array of n numbers, and what you're basically trying to do is the type 1 query is basically set that a index is equal to v. So this is just set the number to or set the index to a number, right? That's what this is about. Cool. So that's the first type of queries, right? The second type is the one that we really want. The second type is basically 1, 0, and I. I don't know why they've given a 1 and 0. It really doesn't make sense. But what 1, 0, and I tells you is find the immediately larger number on the right side, right? Right side of I, such that AI doesn't exist in 0 to I. So it should not exist. You guys all understand the inclusive bracket, right? Should not exist in like indexes 0 to I. Doesn't exist in indexes 0 to I. And j minus I is minimum. So it's the first immediately larger element on the right side, right? And so whatever number that you get there, so let's say we get k, take XORs of all such k. Basically, that's what we want to do, because the result of this query is always 0. So 0 XOR something is going to be 0. We have to take an XOR of all queries. First query, XOR will be 0. So that really doesn't help us out. All the next queries is what we want to take the XORs of. Right? Okay. 2-3 ways to tackle this one. Try to think of it. Any thoughts, anybody? By the way, yeah, it was asked Okay. But yeah, any thoughts meanwhile, by the way? Any thoughts by the people on chat and so on? Brute force could be. I think it's possible probably to do brute force. We don't know the constraint. So one of the things is, yeah, brute force for each query, you will end up having to go left and right. Can you explain with test case? Yeah, sure. Let me actually do that, right? As usual. We should always take a test case. So I would assume, because again, they have not given or at least the screenshot has not given. I'm sure they would have given, but the screenshot has not given. So I can't really say, what's the case here. Unless the person who shared it with me, do you have like a screenshot of this? That would be helpful. Oh, yes, it is there. Yeah. It's there. It's there. It's there. It's there. Cool. Let's go back and check. There are more pages in that. I didn't check. Anyways, right? Okay. So n is 10 raised to 5, m is 10 raised to 5. Okay. So there goes our brute force approach. Because there'll be m queries. For each m queries, if you do, it will be nm. So we are going to basically get out of that. So that's not a problem. I mean, it's not going to be possible. The first line. So they have given us an example 2215101, right? So let's try to understand what that's about. 1 second. So they've given example 2, 2, 1, 5, and 1, 0, and 1. Must be a very simple query. So the idea here is the first line contains an integer n denoting the number of elements in A. So there are 2 elements in the array A. Next line contains integer m denoting the number of rows in queries. So there are going to be 2 queries. Then after that, each line I of the subsequent n lines contains AI, and then you have your queries. Contains 3 separate integers describing the queries. So I think one of the queries has got cut off over here. Yeah. So 1 second. I think there might be just be more. Yeah, here we go. 101 and 100. Right? 100. There you go. All right. So let me just write that down. Let's first try to work it out ourselves, and then we'll see what they mean. Right. So let's go here. All right. So the question looks like this. What do they mean by this? That there are, first things first, 2 here means 2 elements in array. This means 2 queries. These are the elements of the array 1, 5. So you actually have the array 1, 5. Okay, and then you have 2 types of queries. The queries will be, and just first check again. So the query we'll get from that type only. Okay, so if the query starts with 1, it's a type 2 query. If it starts with 0, it's a type 1 query. So it's both type 2 queries. And the idea here is 101 and 00. So basically what you need to do is you need to find so 1 at index 0 and index 1, right? So you basically need to find how would you find for 5 though? Good point. Yeah. Find the immediately larger element on right side of I such that A of I doesn't exist in indexes 0 to I, or rather A of K, J, and say we get K, take XORs of such K. So if it doesn't exist, because we can't find on the right side, so I guess they must have mentioned something about if it doesn't exist on the right side. If it is given that if the result of a type 2 query cannot be found, you take the result as 0. So here I cannot find a number. So it's just given in the question. I cannot find. So for example, the first query basically saying that at index 1, find the greatest element on the right side, find the nearest element on the right side, which is greater than this index, that is 5, right? And it should not occur on the left side. But I don't have anything on the right side. So this query ends up returning 0 because I don't have anything on the right side. So I'll end up returning 0. What about this one? I should return the greater element on the right side, the immediately greater element on the right side, which does not exist on the left side. So that would be 5, right? That would be 5. So this query returns 0, this query returns 5. And when I take 0 XOR 5, I get 5, right? So the answer of this one is 5. That's what this one is saying. The answer of this one becomes 5, which is what the output is also, I'm assuming. Let me just check. Yeah, so the answer is 5 for this one as per the question given. Let me see if we can get anything else here. Yeah, we are able to get another one. Yeah, Somebody saying explain again. See, they are told that there are two types of queries, right? So queries are of two types. Either the query is like 0, index, and v. In this case, I actually go to that index and set the v, right? And the second one is 1, 0, and some I is what they're mentioning. And what you have to do is, for the result of this query, the result of this query is always 0. Result is always 0. You just go to that index and set v. In this query, 1, 0, I, you check for index I, the greater element on the right side, the immediately greater element on the right side. You need to find that. If you find a particular element, great. If you don't find any element, you have to return 0. This is what we did over here. So when we did 1, 0, 1, there is no element on the right side greater than 5. So hence, I'm not able to find anything. I just return 0. If I am able to find, so 1, 0, 0, I'm able to find an element on the right side. I find that it's 5. So I return 5 over here. So it becomes 0 XOR 5, which is equal to 5 at this point, right? That's the answer there. Okay. Let me just take one more example and see if it's, if it helps out anything with the logic or not. Okay. So the is 4, 2, 2, 2, 4, 2, 1, 3, 0, 1, 1, 1, 0, 2. Okay. So here we have a 0 type query as well. So the idea is, this is 4 is number of elements, 2 is queries. These are the elements. So I get an array of 2, 2, 1, 3, right? If I have to put the indexes is 0, 1, 2, and 3. These are the indexes. And this is one query. So the first query, what happens is 0, 1, 1. What is this query? Go to index 1 and set it to be 1. So this is the result of the first query, and I return 0. So that's not really going to bother us. What about the second query? I'm saying go to index 2 and find the immediately greater element on the right side, which is 3 for us. So this result is 3. 0 XOR 3 comes out to be 3, which is also correct at this point, right? That's also correct there. Lastly speaking, let's look at one more if they've given us. They've given us one more as well. Let's just see that. So meanwhile, everybody else who's understood the question, just try to think of the solution, how you would try to do it. 4, 3, 1, 4, or 3, 1, 4, 2, 2. This is another kind of problem. 0, 3, 1, 1, 0, 2, and 1, 0, 0. Okay. And the idea here being that this is elements, queries, 1, 4, 2, 2 is the array. So 1, 4, 2, 2. Right. And then you have 0, 3, 1. So what I have to do is go to index 3 and make it 1. Right. That's what I did. This becomes index 0. So return 0. Go to 2 and find the largest element on the right side. I don't have any such largest element on the right side. So what am I going to say? I'm going to return 0. Go to 0 and try to find the immediately larger element on the right side. So in this case, the immediately larger element on the right side is 4. So 0 XOR 4 will be 4 itself, right? So answer here is equal to 4. Again, so they've given all straightforward stuff. They've not really given too much to deal with here. But I hope you all understood what the question is doing. Right now, you guys have understood what the two different queries are at least trying to do. Yeah. Please do give me a yes on the chat if you've understood what the queries are trying to do. Right. Okay, super. All right. Initial thoughts, everybody. Initial thoughts on how we could go about solving it. Initial thoughts. For every second query, we can add the query in a set and take element after ith element. This will take out the duplicates. So the thing is, I cannot keep the second elements or the second query separate and the first query separate because they are happening sequentially. It could just so happen that between two type 2 queries, the type 1 query comes in and updates something. You understand? So I can't really put all the type 2 queries away, right? So what somebody's saying is that you keep the type 1 queries on one side, and at least for the type 2 queries, just create a basically, just figure out for every index what's happening, what's the largest element on the right side, immediately larger element, and accordingly just kind of update that, right? But I can't do that because the type 1 query might come in and just interrupt me. That's the reason. And the other catch which we have not seen is that the larger element on the right side must not be equal to an element I have found on the left side. So it could be immediately larger, but if I could find something on the left side which is same, then I will still keep going further. Okay, that's the that's the idea here. So it is a little bit complicated in that sense. Obviously, the brute force approach is fairly straightforward. This is what we've been doing right now. Just execute each query as is, right? That's what we'll do in the brute force sense. But okay, so if I had to think about it, there will be 2-3 things. This is how my thought process would go over here. Okay. Yeah, so brute force here is exactly as you said. Brute force here is just go one by one, and as per the query, just execute it, right? And that's what you'll do. And see, brute force execute each query as per instructions, right? So that's what you'll do in brute force. And if you start doing that as per the instructions, right? Each query, like type 1 query is order 1. Type 1 query is order 1 because that's straightforward, right? Like you just have to go and update a value. But type 2 query is order n itself, right? Type 2 query in itself is order n, and you will realize that I have, is it order n? Because I have to go left side and I have to go right side for every query, right? So it will be order n, and I will realize that because I'm doing this for every m queries, therefore the overall order becomes order m into n, right? The overall order becomes m into n. That's a problem. And this is okay. I mean, it would have been okay if, let's say, m and n were, let's say, 10⁻3, you could have still given this a shot. But what they're mentioning to you here is that m and n are both 10⁵. So you're going to get in trouble there, right? So obviously 10⁻10, it's way too much. So it's going to be time limit exceeded. Okay. So somebody saying, will brute force pass 60% of the cases? No, I think it will pass probably in this kind of questions. It'll probably pass maybe 20% or 10% of the cases. So I would not spend too much time on the brute force right now. Like I would not say that, go for the brute force here, try it out. You might be able to get it. It's clearly they want you to think of something else. So approach, let's think of the approach a little bit. Okay. My gut tells me something is up with XOR. That's what my gut is telling me. I've still not figured out the solution. As you saw, I just saw the question. I don't even got time to do rough work. But excuse me. But my gut is telling me that there is something up with XOR over here. Why is something up with XOR is because they are not asking you to find the greater number on the right side every time. Like it is a part of the query, but that's not the real deal. The real thing that they're trying to do is they want this XOR of all of the queries, right? That's the thing, right? So that's the idea over here. I think something is up with XOR here. Now, how will the XOR really help us out is what we need to figure out. Because why did they ask us to take the XOR of all of these numbers? Why have they asked us to take the XOR? Somebody saying, if we take XOR all duplicates, finish. First of all, very eloquent. Means like it's very descriptive what you're saying, but I'm being sarcastic. But no, really speaking, removing duplicates is not really the big issue here. You remove duplicates, okay, but you might still have all the answers to be unique elements, right? So that's not the case here. Let's just spend 2 minutes, everybody, and think on this. I think something is up with the XOR part. Let me just think on this one. I get those queries. I will, for every query, I'm going to put on the right side. I'll check on the right side. So it might have been done, and this should not have come on the right side. Okay. It's a unique element. I'm told that it's a unique element. Somebody's asking with a very interesting username, how many students hired Infosys through HackWithInfy exam? They hire only top 100 students or more than 100 students? Oh, they hire many, I think thousands of students. They hire thousands of students. It's not just the top 100. Don't worry. They don't hire lots of students. Okay. Anyway, concentration time. What happens if we take XOR of all the numbers? The duplicates will go. That part you're right. What will happen if we end up taking the XOR of all? If I try to take XOR of all, just give me XOR of the numbers. It's not going to help me out too much. What we could do, the easier problem to solve would be if the query 1 was not there. Let's look at it this way. If the first query was not there, then solving the second query was very easy, because we would get the minimum number on the right side, right? We would be able to get the minimum number on the right side. It would be a little bit more difficult than the finding, the maximum number. But my point is that it would be a little bit easier. It would be a little more difficult than finding the next larger element, because we would have to modify, because it could not have occurred on the left side. So it should not have occurred on the left side and still be the next larger element, right? So let's say the type 1 query was not there. The type 2 query would be easier, because just let's see, if I had to do just type 2 query, then I can do it because I'm just doing the next larger element at that point, right? Is that kind of clear to everybody? And next larger element can be found in order n. I'll just generate the entire next larger element array once, and that's it. Then every time I do a type 2 query, I'm very easily able to figure out the answer, right? That much is clear, right, everyone? But this type 1 is the one that is bothering me at this point. Initially, all the elements are unique. No, they've not given that. No. So see, if I were just to, okay, so somebody's saying that, why, sir? What's the issue? Okay, cool. See, my thing is, what is type 1 query asking? Type 1 is just order 1, yes, but type 1 is messing up the answer, right? That's what I'm saying. See, let's say for assume we don't have type 1 query. Okay. Yeah. Assume we don't have type 1 query. So let's say we get, if it's just type 2 queries, type 2 queries is essentially find the next larger element, right? Find the next larger element for every index I, right? Also, that element should not be in 0, I, right? It should not be in 0, I. So it's just a modification. What I could say is, this is a modification of known algorithm. And what is that known algorithm? Next larger element, right? How would you actually modify it? You would basically, right. So how would you modify the next larger element? Basically, you could, while finding the next larger element, just ensure that for somebody saying, while storing the elements in the array, we can check if it already exists or not. We have to check on the left side if it exists or not. And again, it becomes order n square. You understand? So you can't do that. Yeah, for next larger element, what you said, you would have to do order n square then again, right? Because every time you're figuring out, see, from the stack, what you're going to get is, even using array list, just imagine, how does next larger element work? If you remember, you come from the right side, yeah? And when you're coming from the right side, you're always inserting the particular element. But the element that I'm choosing, I should be sure that it does not exist on the left side. That is what my issue is, right? So it should not exist on the left side is what I should be doing. Right? So I use the stack. So I think this you guys can do, but it's a combination of either you have to use a set or a map to figure out where this array comes. If you can use a particular map to figure out for each number the locations at which it is coming, right? If you figure out for each number the locations at which it is coming, then whenever you do a next larger element, just check that does this number come to the left side or not. Does this number actually occur on the left side or not? If it occurs on the left side, okay. If it does, then you have to pop it out of the array, use another next larger element, and so on. That's what you basically try to do, right? So it's a good modification of the next larger element thing, if we were only focusing on a type 2 query, right? But on top of that, our bigger issue is now that the type 1 query might even change the type 2 query further. For every second query, create a set and add elements and take the next element of I. What will you add? Which elements will you add? So you will, for every second query, create a set and add elements. Which elements will you add? Elements of the right side? All the elements of the right side is what you're going to add. So I'm saying first remove all the elements of the right side which are in the left. That will not help you. That's not help you out. Just think about it. It will not change the array, and we can. So you're saying you'll add all of the right side elements into a set. Okay. Then how does that help you? We want to avoid order mn. This is again, we have to bring it to order m plus n at max, right? Or even below that. This is also fine. Okay. So the idea here is, everybody, it's a modification of the known algorithm next larger element, where it's not just the next larger element. This element should not have occurred on the left side also. That's all we're asking over here, right? With a little bit of stacks or a little bit of this thing arrays, you can figure this one out. I don't think that this will be too difficult. If it was just the type 2 query, if there was no type 1 query, you would be able to figure this one out. You would probably use a map for every element, try to figure out where all this element has occurred, the indexes on which it has occurred, right? So if I knew which indexes, so guys, what I'm trying to say is, let's say, for example, right, you have the array, 5, 1, 4, and 5, 1, 5, 2, 1, 5, 6. All right. So let's say you have the array this. Okay. If I have to find the next larger element for each of this, as per the type 2 query, let's say this is the array. Okay. And if I have to find the next larger element for each one of these, how would it work? I would always start from 6. So for 6, I don't have an element on the right side. It's greater than, so it'll be -1 over here. For 5, I do have an element on the right side, which is 6. Okay. For 1, the immediately larger element to 1 is what? It is 5. But the question very specifically says that I can't use 5 because 5 also occurs on the left side of 1. Are you all understanding? For 1, I can't choose this 5 because it is already occurring on the left side of 5 as well. So what I need to choose is choose another number greater than 1. And that number happens to be 6. So here also it would be 6. Okay. For 2, the immediately larger number is again 5, but I can't because on the left side of 2 occurs 5. So I can't choose that. I have to choose 6. So it's going to be 6 for this. And even for this 5, it's going to be 6 because immediately larger number on the right side is 6, right? And 5 is not greater than 5. Are you all understanding how this next larger element looks like modified? The usual next larger element, right, works as to as finding the immediately larger element. But here it's not saying that it's not just about choosing the next larger element. It's about choosing the immediately greater element and which has not occurred on the left side. So that's one thing. Somebody saying, can we do this using sets? You do it however you want. I'm not saying that. I want you to understand logic. Implementation we'll figure out later. So, okay. The second thing is, so if you can modify, if it was just a type 2 query, you could have modified this next larger element to do this kind of a logic, right? Obviously not in n square time, but in order n time. What would you have done? You would have basically created for each number. So let's say for 5, I know it occurs at, for 5, I would have created that it occurs as index 0 and index 3. For 2, I would have said that it occurs at index 1. For 1, I would say that it occurs at index 2. For 6, I would say that it occurs at index 4, right? This is what I'm saying. So I create this kind of a dictionary or a map to figure out like where all, the numbers exist. The moment I try to put for this 1, I try to put the next larger element as 5. I check, does this basically has 5 occurred before or not? So I go to 5 and see, I want to put you over here, but you are at index 3. What I'll say is 0, 1, 2, 3, and 4. So I'm at index 2 right now. I'm trying to put 5 as my next larger element, but when I go to 5, it says, hey, I also occur at 0. I also occur at 0. So I would become ineligible for you. Okay. Let me go to the next larger element after that. So I will pop out 5 also from the stack because it's ineligible for me. If it's ineligible for 1, it might just be ineligible for 2 as well. So I remove 5 from that. I go to the next element in the stack, which becomes 6. This will make sense for all of you if you know the next larger element algorithm, which I do not have the time to cover right now. We do it in the DSA course. But yes, those whoever are DSA students who done stacks with us, I think you would remember this. But the idea being that you can basically, via stacks, do this. You pop out further by checking the dictionary or where all it has come. If this was just a type 2 query, again, I'm trying to tell you, like if this question was just about type 2 query, this is how you would do it. Okay, this is the way to kind of solve it. But type 1 query comes and kind of complicates things further, or does it? I'm just trying to figure out if type 1 query comes and complicates things a little bit further over here. So I'm trying to think. In the type 1 query, I could go and update the dictionary. That is one thing I could do. But then the stack gets also messed up, right? And I have to reconstruct the stack completely again. So I can't just come here and just update. Again, we have not even come to the XOR part. Like, but just type 2 query, it's fine. So this still is order NM? No, this is not order NM, because once you create this, basically this array, this is just once, order N. Then every time you will just go and query this array, right? You'll just go and query this array, because all it's asking you is, okay, it asks you, let's say 10I, it asks you 102, let's say, right? So then I will go and basically go to order, it will be an order 1 answer for this 10I. Type 2 query becomes order 1, but we pre-compute it over here. But how to check if it is present on left or not? Simple, like when you have I, you check that when you are populating from the stack, how do you populate? How do you do next larger element? You will put 6 on the stack, then 5 goes on the stack. Then when you're at this index 2, for 1, I want to use 5. I go and check, hey boss, 5, are you available to be put? 5 says, I also exist on index 0. Oh, you also exist on index 0? I don't think you're available to be put. In fact, what you could further do is store this as a set. Don't even store this as a this thing, right? So yeah, so we have to create the map first. You're right. You have to create the map first, store it as a set, so you'll easily come to know whether this particularly exists or not. That's all. So we're saying, yeah, I'm not even talking about type 1. I think you're still worried about that. I'm talking about type 2 only. If it was just type 2, how would you do it? Just telling you all, because this could be another question, right? So just for type 2, if you had to do, this is how it would be. Okay. So what about type 1, everybody? What about type 1? But now type 1 query comes and messes up our entire array. And because it's messing up our array, we are getting certain issues here, right? So I'm just trying to think. Can we work with something on XOR here? So we're saying for every first query, we can do changes in map. Yes, you can do the change in the map. I'm not denying that. But you will also have to come and update the next larger element array. That's the bigger issue. Yeah. And then you have to recalculate this thing. Because let's say somebody comes and makes this as, let's say 0, right? If this becomes 0, then okay, you can remove it from here, but now the next larger element for, okay, or not just this, if let's say somebody comes and makes this a 0, now the next larger element for 1 is 0 on the right side, right? Because 5 I can't still use, so it has to become 0. So this entire thing has to be computed again, basically. This 1 has to become, for 1 it has to become 0 and so on, right? For 5 also it has to become 0. So that's the issue. I can't just, update the stack all of a sudden. My bet would still be if we figured out a way of updating the stack. No, I don't think there's a way over there. Okay, got it. Why have they asked XOR though? Why have they asked XOR? There is something up with XOR, everybody. Right? Let's just figure out. Let's go back. Something is up with XOR. Why have they asked you for XOR? Why have they asked you for XOR here? Because if I give the number is like that. It's a particular number. Greater element on the right side. Yes. Right. Greater element on the right side would mean it already exists before, then a greater element on the right side would be a little bit more than that. Means there is a change in the number, there is a change in the digits, and that particular digit is, there is a more significant bit greater. So if I'm looking at the right side, it means that I have a more significant bit greater than, there is a particular significant bit greater than my current bit, right? and that's why it's causing it to be greater on the right side. Okay, cool. When I do XOR, what's going to happen? All of the same bits are going to remain same. All of the other bits are going to flip. Fair enough. All the same bits going to become 0. Otherwise, they're going to flip. So if I just had to look at the type 2 query, I'm finding the immediately greater element on the right side, which would mean, okay, cool. Yeah, there is something to do with XOR here, I feel. What's going to happen is we have some bits, right? So let's say you have all the bits, let's say 31, all the way up to the 0th bit, right? You have some bits like this, you have particular bits here, and something like this. These are all your bits, probably. Right? More than that, right? Because there will be 31 bits. Here I'm putting only 26, but you get what I'm trying to say. So there are certain bits here, and the CD right there. Every time I take that, I want to find the next number that's greater. Let's say I do. Keep thinking, everybody. I want your solutions. You also have the test tomorrow, so please keep thinking on your end too. Okay, good. So okay, others, any thoughts? Others, any thoughts? Something with the bits that's forming in my mind. I'm going in the direction of the bits somewhere, but any thoughts forming in your mind? Somebody's saying, as we know that which element we have to change in type 1 query, so we can directly modify each next greater element. Not really. I think we don't need to worry about the bits if we can figure out how to do the type 1 query and still not affect our next larger element array over here. And the one of the ways of doing this is by figuring out the next larger element on the left side, right? We can, basically speaking, use both next larger element on right side and next larger element on left side to do something for us. So for instance, if we have this as our array, okay, if I had to keep the next larger element, right, the way I would, let's say we didn't have any constraints that it can be equal to the left side or not. We don't have any of those constraints at this point. So we could, possibly speaking, our next larger elements would look something like this: 6, 5. Let's say we had no constraints. 5, 6, right? And -1. We had no constraints. That is, it cannot be equal to the next line and so on, right? So this is the next larger element on, let's say, right side, right? That's that. Then let's say we had next larger element, nearest larger element on the left side. Let's say we're doing the left side, right? So for this, it would be -1 because I don't have anything, right? For this, it would still be 5. For 1, it would still be 5. And for 5, 8 would be -1 because I don't have anything greater on the left side. And same thing here, it would be -1, right? Now, let's say a type 1 query comes in, a particular type 1 query comes in and it updates some value, right? Like, let's say it comes and updates this value to be it updates this value to be okay, and just before that, let's also create like occurrences array, occurrences thing. So the occurrences, it happens that 5 is at 0 and 3 index. 2 is at 1 index. 1 is at 2 index. 5 we already took, and 6 is at 4 index, right? So 6 is at 4 index. Cool, got it. So now the idea here being that the next larger element on the right side Okay, so let's say we come and update. So let's say we want to update this particular one. Let's just say if you're updating this particular one to, I don't know, let's say 2, it won't really affect anyone because 1 was never here anywhere, right? So here we don't have any issue because neither this gets affected nor this gets affected, let's just say. So this one is harmless to update. That's okay. Harmless updates, we don't really mind anything. Fair. But let's say, for example, let's just say that this 5 was updated, right? So this is a subset. Yeah, one second. We'll discuss, guys. Today we'll go for a long session. Don't worry, right? We'll discuss all of these. Yeah, as I was saying, so let's say this particular 5 or the 6 was updated to, let's say, 4. If this 6 is updated to 4, then this 5 also should become -1. How do I know that it will become -1? How can I go ahead and update that without having any issues? I will keep updating it till the next larger element on the right side. Correct. So I had 5 here. I don't have any larger element. Right. So most probably this 5 was the one that was the 5 for everybody. So this continues to remain the same for. All right. Got it. So this 4 will just need to update this -1 and this one will become -1. That's it. And post this, we don't update because there was no element greater than 5 in the first place. Cool. Okay. That kind of makes sense. Okay. So we have got the updation of this one down to, I mean, it could still be something like, it will still be an order n updation, but yeah, at least I have figured out till where I have to go and update it. So every type con query, I can update the next larger element on the right side and the next larger element on the left side. Okay. All right, cool. So I think there is something to do with this one. Let's just wrap this one up in a bit because I don't want to take too much time. I could also always just release a separate solution for this one as I figured this out. But most probably, so I have sent a 3 questions. Please look into it. Yes, boss, I will. Yes. Okay. So the question, the update that I have for you all is to ensure that we can always look at this in order m time, right? In order 1 time. What you could do is you can create the next larger element on the right side and also create the next larger element on the left side. And the moment you get an array update, so let's say, for example, what was it earlier? It was something like this, right? So it was something like this, wherein this is the next larger element for the right side, meaning that for 6 on the right side, I have -1. For 5 on the right side, I have 6. For 1 on the right side, I have 5. So that's why you have 5 here, 2, you have again 5, and 6, you have again 5, and so on. And you also figure out for each element, what's the next larger element on the left side. Meaning for 6, what's the next larger element on the left side? I have nothing. For 5, what do I have on the left side? I have nothing. For 1, what do I have on the left side? For 1, you do have 5 on the left side. For 2, what do you have? You do have 5 on the left side. For 5, you have -1, nothing over here. Now, how does that help us? Let's say some 5 comes here. Somebody comes and says, update this one. So update this one to 4. Okay. If I updated this one to 4, let's say, who all will it affect? It will affect all the elements on the left side. It will affect all the elements on the left side, which are lesser than 4. Are you guys understanding that part? Only those elements on the left side lesser than 4 are going to be worried. Meaning, I have to go till where? Till where do I have to go to update? I know that I have to update only till a particular point, not more than that. And where do I know? See, this was the next larger element on the left side for this one was 5, right? So was -1. I didn't have any other element on the left side, meaning that this 5 that was here was the next larger element. 5 was the next larger element for a bunch of elements on the left side. This 5 was the next larger element for the bunch of elements on the left side. Which ones? All of which have 5 on the left side. So the moment I chose this 5 to 4, I can also go and say that all of these have to be changed to 4. I don't have to worry about which ones have to, like, should it be changed to 4 or 6? I don't have to figure that out. I know they can automatically be changed to 4 because both of these had 5 in them. And which 5? We are referring to this 5 only. Till when do I keep updating it? Only till this one, till it becomes, let's say, -1, or till it becomes some other number over here. Let's say, for instance, you had the number here, let's say 12. At that point, no, sorry, that would be a wrong answer. Yeah, but my point is you keep updating it till you have another number. So for this 5, I got -1, meaning that I had no element on the left side greater than 5 in the first place. Did I do this wrong? One second. No, this will continue to be 5. Sorry, this will continue to be 5. Oh, no. These will continue to be 5 because we're looking at the left side here. Yes, I was talking about updating this array. Yes, I was talking about updating this one. You keep updating this one. You keep updating the right one. So you will update this to 4. You're going to update this one to 4. And you're going to update this one to 4. But you're not going to update that 6. Why are you not going to do that? And furthermore, you're not going to update anything else. The reason being that these are the ones which were still greater than, which had the next larger element as 5. So you update them as, no, now the next larger element for these are 4 at this point. And you keep going till you find a -1 here. Basically, here you had next larger element on the left side as 5. I keep going because 4 is less than, till I reach that 5, I will keep updating that 4, is what I'm saying. So I know I was a little disjointed. Let me just start again. My query 2 is going to pick from this array, the next larger element on the right side. The query 2 is always going to pick from this particular array. This query 2 is going to pick from this array. Okay, great. If my query 2 is going to pick from this array, what I need to do is I need to keep this array up to date every time, because a query 1 will come and mess this array up, right? So what I need to do is whenever a query 1 comes and messes the array up a little bit, like this one, like this 4 over here, right? I need to know till where I am going to go and keep updating this one. Okay, I will keep updating this one till on the left side, the next larger element I get is not greater than 4. Meaning that the first element greater on the left side is which one? Is 5. So I need to keep updating till it is 5. Till this 5. So basically I go and update these to 4. Now, next larger element on the left side should be 5. So up until 5, I'm going to keep updating it. Why only 5? Why am I not going further? Let me take a better example to show you guys. So it makes sense in my head, but just to show you guys, let me just take a better example. Right. Let's say this was initially 5. This is 5. Let's say this was 5 and this is the case. Let me just change the number a little bit. Let's say this was initially speaking 5 only. And now let's say I made it 12. Initially speaking, it was 5 and now I've made it 12. Okay. No, let me keep it 5. I just want to show you guys. Six and -1. So this 5. Why do I keep going there? Because, yeah, okay. I want to take a better number, a bigger number on the left side, the bigger number on the left side. I keep going till I find a bigger number. Basically, what I'm trying to say is if this 5 was updated, this 5 will affect whom all? 5 will affect whoever had used this 5 for whoever had used this 5 for its next greater element on the right side, right? It's going to update, it's going to affect those. How do I know for sure that this 5 will affect all of those? I will keep going till the left side till I find an element greater than 5. Because if I find an element greater than 5 on the left side, then that new greater element is going to be the boss for the lefter elements, right? So we have no issues there, right? But this change in 5 will affect every element on the left side. That's the issue, right? So for instance, let's say this 5 becomes, if this was a better number, let's say this was 3. Okay, so now let's say this 5, for example, becomes 2, right? Now this 2 still has 6 as the greater on the right side, but this updated 2 is going to affect all the elements on the left side. But I don't know till where I have to go on the left side, right? So this is where this works out, because earlier I had 5 over here, right? Earlier I had 5 over here. For this number, the greatest element on the left side, there is no greater element than 5 on the left side. There is no greater element only than 5 on the left side, right? That's why it gave us -1 earlier. Means that there was nothing on the left greater than 5. Meaning that this 5 was the answer for a bunch of numbers on the left side. But now I made that 5 to 2. Now, if I'm making that 5 to 2 over here, what does that mean? It means that a bunch of numbers are going to be affected on the left side. But which numbers are going to be affected on the left side? Actually, all the numbers are going to be affected. Why? Because all the numbers on the left side, there was not a single number on the left side greater than 5. So all the numbers are going to be affected. So I need to go and update all. How will I update all? As simple as, when I go to 1, I check the new number or the number that was greater for 5 itself earlier. So for 1, I check the new number, which is 2 or 6. I will choose 2 because that's the one that's better for me. Okay. So I'll check either 2 or 6 because that's the one that's better for me. And I go for 2 because 2 is the one that's nearer. Okay. Then what do I check? Okay. I will check either 2 or I will check 6. So I got 2 over here. Okay. Fair enough. Then I come to 3. Even 3, I can check either 2 or 6. If this number, this 2 is not helping me, so I need to go and update it to 6. This is what. Why did I even check 6? I checked 6 because this 5 is the one that was displaced. If 5 was the answer for some numbers before me, then 6 will definitely be an answer for some number before, right? So the moment that 5 got changed to 2, automatically I go to the left side and try to update the numbers. Till when do I update the numbers? I will update the numbers for every number out there, right? Till when? Till, actually speaking, I reach a -1 over here, because till that time I still have a 5 on the left side. Till that time I still have a 5 on the left side. I'm trying to still reach it. That's what I'm trying to do. So I'll keep going till I get basically a number greater than 5. I didn't get a number greater than 5. So it means that I've actually reached the end, right? So this way, it's still an order n updation though in the worst case scenario, because let's say, let's say 6 itself was changed. So it would still be an order n updation. So type 1 could still basically cause you order n over here, is the issue, but it's a little bit faster. Yeah. So it's a little bit faster than the previous one, where we were, for every query, we were going to the right and left and checking, right? So this is an order n updation, but it's an order n updation of the m array, not for every type 2 query. We are not doing this, right? So it's still order n, but it will save you some, and it will help you pass some test cases, right? It's going to help you pass some test cases. There might be an even better way of figuring this out. So I'll just work on this a little bit. You'll see a solution uploaded on this channel in sometime soon. I realize I've gone up, but we've discussed this problem only for 90 minutes. So sorry for that. This is an interesting problem, but yeah, we ended up taking a lot of time on this this problem here. So let's go on to another one. My point is, this will be better than your order n into m. Technically, it's still order n into m, but it'll be slightly better. Because you're not doing it for every type. For every type 1 query, you're only going a certain distance, not the entire distance. A certain amount of distance is what you're going. And for type 2 queries, it's going to return in order 1. So at least earlier, what was happening? Type 1 query was fairly standard, and type 2 query was order n every time for sure. Like you are going to do order n because you're checking the left side, you're checking the right side, and so on. But now we've reduced that a little bit, and we've made it such that the order m, so the type 2 query will always be order 1, and the type 1 query will at worst be order n, right? It's going to be at worst order n, but not always order n. Okay. So I think it's a little bit of an improvement, and let me think of some more ways to improve this a bit further going ahead. Okay. Let's quickly look at another problem that was there. Let's just see if we can get another problem here. Okay, so this is the other one. Okay, Given an array of n integers, a subset of that array is considered valid if the following conditions hold true for it. The subset is empty or consists of exactly one element. The distance between the indices of any two consecutive elements of the subsets is greater than equal to a with respect to ARR. Distance between the indices of any two consecutive elements of the subset is greater than or equal to a with respect to ARR. The distance between the indices of any two consecutive elements of the subset is less than or equal to b with respect to ARR. Okay, fine. You are to find the maximum possible sum of a valid subset from the given array, since the answer may be large. Okay, cool. What is the input format? First line contains a, n, next line contains integer a in the problem, and contain b denoting the value. Okay, n, a, b. Okay, so you have to basically figure out the subset, and the distance any two consecutive elements of the subset is the distance between the indices of any two consecutive elements of the subset. Subset means you can choose any particular element. Subset is empty or consists of exactly. Yeah, what does this mean? Subset is empty or consists of exactly one element. What does it mean by subset is empty or consists of exactly one? So there has to be only one element? That doesn't, I think the first one is a little weird. What does it mean by empty or constraints is this? 10 raised to 6 element, and this is 10 raised to 9. So yeah, it's an order n solution or even lesser than that. Okay. Okay, let's look at the question here. Do they mean sub array or subset? This is the other issue. You can never be sure with them. So okay, somebody saying you can solve it by segment tree. Okay, if you can do it segment tree, then please go ahead. So 10, 1, 1, minus 6, 1. Six, 1. So basically the array is 10. 1 is A is 1, B is 1. Okay, and then you have minus 6, 1, 6, 1, minus 6, 1, 6, 1. 3, 9, minus 6, 6, 7, 10, 0. The indexes here are 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. All right. After this, we'll go back to our questions, everybody. Don't worry. We'll not spend too much time on this. We'll just go back to our question. All right. So this is the thing that's being asked. The question is, so the original array that's given is minus 6, 1, 6, 3, 9, minus 6, 7, 10, 0. Yeah, that's correct. And we should choose, okay, we should choose a particular set of numbers such that the distance between the indices of any two consecutive elements of the subset is greater than or equal to A with respect to ARR, or greater than or equal to B, and the distance between the indices of any two consecutive is less than or equal. So here we can, basically the thing is, here we are supposed to choose a set of elements. Any two consecutive elements that we choose, their distance should be greater than equal, like A is then equal to B, right? That's what the distance should be, the distance in their indexes. Okay, that's one thing. Okay, fair enough. And what is this question called, by the way? Anything? Okay, no name of the question. Anyway, and you have to find the maximum possible sum of a valid subset in the given array. I have to find the maximum possible sum of the valid subset, meaning that, okay, so here, okay, cool. See, the thing is, if I choose one, right? Let's say I choose the indexes. Let me just talk about the indexes right now. Don't worry about the actual number. But if I choose the indexes, then I can choose index 1, but I have to choose index 2 then, or I can't choose anything at all. You understand? Like I can't choose index 3 because the distance between 1 and 3 would be less than equal to b, right? So I have to end up choosing index 2. The moment I do 1 and 3, the distance is not less than equal to b. B here is 1 and a is 1. So basically my indexes can only be consecutive here in this case because 1, a and b are both 1. So I could choose the index 1, 2, 3, 4, 5, right? I could basically choose this particular index over here, right? I can't, like, it's best I don't choose index 6, or actually I could, end up choosing index 6. Maybe that by choosing index 6, I'm able to even go further than that. Okay, I think this question becomes kind of straightforward then. Yeah. So if I choose like 1, 2, 3, 4, 5 as a subset, the sum of this becomes 1 plus 6 plus 1, 8, 11, 20. So the sum here is 20, right? If I choose this, sum of elements on indexes is equal to 20, right? That's what we said. But if I was to further choose, let's say, for example, I had to I further went on, right? So if I just took this, then if I just took 0, 1, 2, 3, 4, 5, then it comes to 20. But let's say I had further gone on, right? And I chose this as well. So this becomes 14, but then it allows me to choose this one. So it becomes 21 and this becomes 31. So if I had ideally chosen all of these numbers, yes, the -6 gives me a hit, but that -6 hit is still okay to take. -6 hit is still okay to take because it's allowing me to take something further. It would be great if I could skip -6 altogether, right? And why would I basically like to skip -6? Because it's a negative number, but I can't skip -6 because the index difference cannot be greater than 1. It can be less than or equal to 1, can't be greater than 1, right? So that's how it is. Understood, everybody? I can't have an index difference greater than b. I can only have less than b, right? That's my issue. Okay, cool. All right. This question looks pretty much like selecting of numbers. As somebody said, backtracking works well over here. I'm sure backtracking can pretty much work out. But for 10 raised to 6, doing backtracking will choose, don't choose, right? DP array. How do you do DP array over here? No, there'll be a better approach here somewhere. If you could do a, right. So basically, the A is also important here, by the way. Here, consecutive elements I can take because it's 1. But if let's say A was 2, then I cannot take consecutive elements. I have to skip a number, right, at every time. Yeah. So for A and B as 1, it's okay. But the thing is, A and B can be anything, right? That's the catch over here. A and B can be anything. Yep. A and B can be anything. And the constraints tell us 10 raised to 9. So I can't really. One other thing is to just generate all the subset sums, but I am trying to generate. Yeah, we could just generate all the subset sums and modify it such that I think we can modify the subset sums. Okay, so let's just hold on. So you all know the DP subset sums thing, right? In subset sums, what we do is we just try to see that what are all the sums that are possible to reach, right? Can you show the answer of this one? Answer is 31 only of this. Right? Here, answer is 31. Answer is equal to 31 because it works better because I can take up all the way till 8, right? But what I was saying was subset sums. We all know what is subset sums. Basically, all the subset sums that are possible to reach, we take up basically a DP array. But no, I think that also is ruled out because we would have to end up creating a DP space like if you look at the constraints, it tells us that it's 10 raised to 9, right? 10 raised to 6 is that, and the space is 10 minus 10 raised to 9 to plus 10 raised to 9. So if you had to take a sum of all the numbers, go to 10 raised to 15. I can't create an array of size 10 raised to 15. So dp subset sums is out. dp subset sums is out over here. Guess got greedy. I can't sort the array. Can't sort the array because the relative indexing matters a lot. Can't sort binary search. I think I can't sort here. How it would work is, how do I select the number? I think this one is simpler. I would not start with a negative number. Start with the first positive number, because starting with the negative number just does not make sense. No, but it could still make sense, because let's say, for example, a was 2. No, but even then I'll start with the first positive number, right? The first positive number that makes sense for me. Yeah, if I start with the first positive number, then I can only choose elements going forward. Yeah, I think backtracking is the simplest one here. Backtracking with memoization, I think, is the best approach here. Yeah, constraints are not good for backtracking, and yeah, I think got it. So I think it's a DP solution. Yeah, I think the DP solution would work something like this. Right. I think the DP solution would work something like this, where what we'll try to do is basically maintain. So for -6, what is the best that can come for -6? Nothing, actually, right? Yeah, we have to check for every distance a minus b in a DP array. Yes, you're right. Correct. Yeah. So I think that this one will make sense. So basically what we'll do is, for this -6, what we'll try to do, it's a 1D DP. Then it will work out. So for -6, so basically we create another array. Let me actually just, I don't know why I'm not doing this on the sheets. Hold on. Just 1 second. It'll just be easier for us to track arrays. Yeah, so DP, 1D DP, it's similar to the GCD split the array. It's similar to GCD split the array. We just have to reduce it a little bit from n square, right? We can just make it order n, basically. All right, let's just have a look at this. Here we go, right? So let's say the array that was given to us was -6, 1, 6, -6, 1, 6, 1, 3, 9, -6, 3, 9, -6, 7, 10, 0, 7, 10, 0. All right, cool. So we were given this, right? We create another DP array. So we create another array here, basically. Just trying to find out. So for -6, we'll basically come from left to right, and what we'll try to check here. -6 is fine. Like -6, if you are choosing -6, then that's it. The point here being that, let's say if I had to choose -6 or not, right? So if I choose -6, then the sum on the left side is what I'll say. Let's keep this here. Sum on the left side is 0. If you do choose -6, then the sum becomes -6 plus whatever was the best on the left side, which was 0. If you don't choose -6, then what is the best sum on the left side? It's 0. So the thing is, if you keep 0 over here, then I'm not choosing -6, which means that 1 has to start with this as the 0 over here. Okay. All right. Let's say I do choose 1. If I choose 1, so the sum becomes 1 over here. Okay. If I don't choose 1, then it becomes 0. Okay. But 1 would be, better to choose here. Now for 6, the thing is, because my a and b are both 1, I can either choose 1. I have no choice of choosing -6 or anything. I have no choice of that, right? So for 6, what I can end up doing is I can either choose 1, right? Or, so what will happen? I can basically opt for 1, which will become 6 plus 1, 7. Or I can say that, let me start a new series from 6 itself. Okay. I would rather have 7 because it's greater, right? Same thing with 1. I can choose to continue with the 7. Or what can I do? I can start a new series. So it will become 8 over here, right? So what about 3? I can choose. So these are all straightforward. 11, 9 plus 11, 20, right? Now this is the thing. I can choose to continue this 20, right? This minus 6 and this 20. I can choose to continue this 20, or I can choose to start a new sequence with minus 6. Does not really matter, because it would have, I mean, I would still choose to continue the series. Why would I still choose to continue the series? The reason is this 14 can still help out on the right side. It's still a positive number. It can still help out on the right side. Had this minus 6 being added over here become a negative number, then I would choose to actually start a new series on the right side. Then it would not make sense. But till such time this is a positive number, it can still add to something on the right side. So this 7 plus 14 becomes 21. And this 10 plus 21 becomes 31. And 0 plus 31 becomes 31. So the max I get is 31. Does not mean that the last answer will be the answer. The maximum number in this array is the answer. So for example, if the 7, 10, 0 was not there, if the 7, 10, 0 was not there, then in that case, we would have stopped at 14 over here, right? And if we would have stopped at 14 over there, then the maximum answer would have been 20, because this is the maximum subarray that I would have got, right? Now, this is okay because A and B are both 1. And A and B both being 1 means that I can do consecutive numbers, right? But let's say A and B were both not 1. So I think they have another, a similar example over there where they've given us, let's just take this, where they've given us 10, 2, 4. So you have 10 numbers, 13, 1, 0, 10, 14. So this is another example. Let's just take that. So they have here 13, 1, 0, 10, 14, 1, 0, 10, 14, right? That's the other one. And 8, 14, 14, 6, 4. 8, 14, 14, 6, 4. Okay, this is the case. And okay, so this is the second one, right? I'll just put basically, right? So that was the first one. This is the second one. Now in this case, A is, we'll also put A and a B value over here. A is 2 and B is 4. A is 2 and B is 4, meaning that if I do start at 13, so this is 0 over here, okay? If I do start at 13, okay, means that, okay, I could start, this is 13, that's fine. Now, if I'm at 1, I cannot choose to continue with 13 because the minimum distance I have to have is 2. So if I do start from 1, I need to start from 1 only over here because minimum distance I need to have is 2. Maximum distance I can go up to 4, but minimum distance I need to have 2 over here. So if I put the indexes, right, to, let's say I put the indexes here. Right, these are the indexes. So for index 1, I need to minimum go to index -1. There's no such index -1. So I can't do anything about that. Now, when I'm at index 2, now I can say that, okay, either you start on your own or you can start from index 13. So what I could do is I said, okay, I'll choose to start with index 0, which is basically the number 13. Now, when I'm here, what are the choices that I have? I have these two choices. For 10, I have either you start from 10 or you combine with either of these. Okay, I cannot combine with 2, right? But I can combine with 1 and I can combine with 0. I can combine with all the way till 3 minus 4. I can combine with 3 minus 2, 3 minus 3, and 3 minus 4. That's what I can do. So I say, okay, the max of this, that is 13 over here, right? So 10 plus 13 will give me 23 is what I can go for. Now, when it comes to 14, I cannot choose this 23. But what I could do is I could start from this 2 and all the way here, right? So from 14, what I can do is, so for 14, I'll choose 13, become 27, right? This 8, I cannot use, for index 5, I cannot use this, but I can use one of these 4 numbers, right? 2, 3, 4, no, only these, right? So 5 minus 4, 5 minus 3, and 5 minus 2, yeah. So 8 plus 23 will give me 31, right? That's the best I can get. For 6, I could use 4, 3, and 2, right? I could use only 6 minus 2, 6 minus 3, and 6 minus 4, right? So for 14, the best one here would be this 51, right? Sorry, 14 plus 27 is 41, right? That's what it would give me. This 14, what can I do? I can do the best of these three numbers, which would give me 55, right? 14, sorry, 45. I don't know what I'm doing. 45. For this 6, the best of these numbers, which would be 47. And for that 4, the best of these three numbers, which would be 45, so it'll be 49, right? So the maximum of all of these is 49. So my answer should be 49, right? That's the answer. Okay. Are you guys getting it? It's a simple 1D DP. What you basically need to do is take the current number and see that can it be added to anywhere between, like from the previous distance. Take the maximum previous sum that you got in the A to B, right? Take the maximum. And the best thing you can in fact do is maintain a heap of size B to A. So that way you won't have to do order n. You'll actually get in order log n the because in this worst case scenario, you're still getting order n square, right? Because let's say A and B distance is n distance, let's say, right? So you'll end up getting order n square over there, which will cost you a lot more. The best thing you could do is actually maintain a max heap of the previous distances. As soon as you advance one, remove the previous number and insert a newer number, right? So if you maintain that heap, you can still get it. Is that clear, everybody? Does that make sense? So the optimal would be order n log n over here. Does that one kind of make sense? See guys, we can get some questions. No, I'm just kidding. But does this one make sense, everybody? What I just said? Just formalizing the approach a little bit. Let me just formalize the approach over here. So maintain a heap contains maximum, basically maintain a max heap of the numbers between I minus A to I minus B in this index, right? For and your dp of I is equal to max of either you are starting, because it could be a negative number also. So either you're starting again from here, that is you're not choosing the number at all, is what I'm trying to say. I'm trying to say that, okay, if you want to skip that number, no. So basically it is dp of max of, sorry, it's max of ARR I minus A to, no, sorry, max of dp of I minus A all the way to dp of I minus B, because these are numbers that we can actually use, right? So I can do dp of I minus A to dp of I minus B. I could either use this plus, by the way, so when I take the max of this number, I take the max of this number plus my current number ARRI. So in this case, I'm actually choosing my number. But in order to choose this number, I do this. If I'm overall skipping this number, I could also just start from this number. So it will still be just, or I could just start from ARRI, which could also be bad, or I go 0. One of these is what I'll go for, right? Yeah, one of these. So your dp of I will be max of this, right? Does that make sense, everybody? At every juncture, I am just saying which number do I choose, right, from my previous numbers. I could choose to continue. Let me just show you what that looks like. This is one choice. This is another choice. And this is the third choice. Okay. Yeah. So the idea being that whenever I'm at a particular point, I can choose to, so let's say I'm here, okay. let's say I'm here, let's say I'm at this index, right? At this index, I can choose that, okay, I would like to continue the series with 8. I would like to particularly continue the series with 8. If I want to continue the series with 8, I can choose from the maximum number from these three indexes. I can continue any of the series that continue from index 1, index 2, index 3. Why? Because A is between A is 2, B is 4, meaning that I can only continue the index. I can only continue. This 5 can only join with 3, 2, and 1. From 5 minus A up till 5 minus B. 5 minus A is 2. 5 minus 2 is index 3 to 5 minus 4, which is index 1. So from I minus B to I minus A, basically, I can choose. If I had to choose them, then I would end up choosing 23. So 8 plus 23, 31. So either I could choose that, or I could say, those all are rubbish. I don't want those anyways, right? I could just start on my own and I could just choose 8, but that would not be wise because 8 does not help me. Or I could say, don't start any of them, just go with 0 only, right? This is particularly useful in the case of negative numbers, right? In the case of negative numbers, I could choose to say that, okay, go with the previous number earlier, which was 20. So minus 6 plus 20. Or, if this number itself was negative, then there was no point in making it more negative. So I don't. No, you'll not have that case anyways. Yeah. I think what you'll end up doing is just choosing or not choosing. You'll not have a negative number. Or that. Yeah, I don't think so you'll have a negative number. You will just end up choosing 0 at that point. So it'll just be this. It's not that you will not choose. It'll just be this or 0. That's it. Right. So either you continue it or you just stop it, because probably using me is not a good thing. So I just stop over there. That's what I do. Yeah. Include or exclude. That's about it. If I'm excluding, then I say, okay, start a new series from here, 0. If I'm including, then take the maximum of the previous and add with the ARRI over here. Okay. All right. Does this make sense? I think this would be fairly straightforward. The only thing over here is you take the modulo with 10 raised to 9 plus 7. Make sure you do that because the sum can be very large. That's the only thing. Okay, clear? These are all the questions that I got by mail. Okay. These are some of the questions I got by mail. I think there might be a couple of more questions. They went to my spam, by the way, just letting you know. So once, can you tell a similar type of question? So similar type of questions, just go to GCD split the array. There is a video on the YouTube channel also, GCD split the array. Just check out Edyst YouTube. You will get that also. GCD split the array. You'll end up getting that one. Okay. All right, cool. Let's get started with the two questions that we had. Let me just show you the particle simulation one first, because a lot of you, how many of you thought of particle simulation? Any ideas on particle simulation till now? So we said today we started the session. Sorry guys for taking so long, but I think it's been beneficial, right, for you guys thinking so much. So I hope it's been beneficial so far. Let me know. Are you guys tired? Is everybody tired? What's the scene? How are things on your front? Questions are very scary. Don't be scared. You'll get the idea. I'm telling you guys, you will end up getting the idea. On the day of the test, you'll get the idea. Don't be scared of the thing. Right? Okay. So not tired, right, guys? I hope you guys are not tired. Or rather, even if you are, be with me. We'll help you guys solve it. Okay, cool. Particle simulation. Yesterday, this was homework. How many of you guys tried this? Any thoughts on this particular simulation part? Tried? Okay, cool. Any particular thoughts on this? Somebody saying this exam is tough. Yes, it is. Trust me, guys. I have had people. We have question setters from Google, Facebook, Microsoft, you name it. Like, I've had the question setters from those companies. They have looked at HackWithInfy questions, and in the first try, even they have not been able to figure out the optimal solution. So it takes a lot of time, right? But yeah, then they still give you 8 lakhs per annum. So that's up to them, right? Can we import libraries? Yeah, you can import libraries of Python mostly. That's not a problem. But again, I'm telling you, so don't be too like, oh my God, HackWithInfy asking this much. Well, in reality, I'm telling you, people who've cracked, I've had people who've really actually cracked Google, Facebook, Microsoft. They've come to me and told me that the toughest questions they faced was in HackWithInfy. So, I don't know what to say to that. Okay. Advantage round also same level. Yeah. So I think the questions I got today were advantage round questions. They are not HackWithInfy questions, and they are roughly the same level. They're roughly the same level only. Okay. So Abhinav, your solution for particle simulation is actually correct. Congratulations to you to figure that out. I mean, really, good stuff. What you're saying is right. Yeah. Okay, cool. This random stuff. We stopped yesterday at particle simulation here, right? And we said that in terms of particle simulation, what we're trying to do is we are given a bunch of elements, and any element can combine with any element. We are not restricting the number of times it is. We're not saying that all the elements have to get reduced, but the idea is any two elements can combine, give us another element, another particle. Let's say, what is that particle that they give us? They give us a particular particle which is a subtraction of the two original particles, right? So they're going to give you a subtraction of the two original particles, and once they give you the subtraction of the original particles, it can further go and combine into another particle beyond that, right? So you have your 101. So what we did was, for this one we took 101, 75, it gives 26, and then we said, okay, you can combine 40 and 30 and give 10, and then 26, 10 will give 16, but this is not the optimal one. You could have an even better one over here, right? You could have a much better one over here, where what you do is you take 101 and 75, which is 26, and you take 30 minus 26, which is equal to 4, and you will not get lesser than 4 over here, right? So the minimum particle you end up getting is 4. Okay. So Abhinav, you've given me a correct one. Awesome. If there was a way of giving you points over here, I would have given you. That's something we're working on to give you points during live classes itself. But others, any thoughts on this question? Very quickly, just give me in 5 minutes, and then I'll continue with the actual solution on this. When will you all start bootcamp on DSN algo? When is the next one? But what's today? March, right? I think April first week, March last week or April first week is when we're going to start on DSN algo. Okay. Okay, cool. So some people have said backtracking. Okay, cool. See, there is a backtracking solution to this. Let's first discuss the backtracking solution. Okay. If you look at it, what we are essentially trying to say is that for each number, one of the two operations, one of the three operations are possible. For 101, we can either choose it to be part of our what do you say, submission, sorry, of our simulation. So you choose it, in which case it will be like plus 101. You do choose it, but it turns out to be a minus 101, let's say, or you don't choose it, in which case it becomes an into 0, let's say. It's one of these three things that's happening, right? So what we're basically saying is, for each number, we are saying that multiply by plus 1, or multiply by minus 1, or multiply by 0. That is what we are essentially saying for each number, right? And so the approach then for the backtracking, although this is not the best approach, but the approach then ends up becoming something like, let's say some f of, let's just basically look at, if I like the sum so far, right? That's the sum so far that I have, and I have a particular index over here, right? So I could say that, go further, either do whatever the sum is plus this a of I, right? Or do f of sum minus a of I, right? And then go to I plus 1 is what I'm saying. Go to I plus 1, or go to, again, you do minus a of I and go to I plus 1, and you go to f of sum and just go to I plus 1. That is, you don't choose this number only, right? And the answer that you'll end up getting, so let's say the overall answer is a global variable, let's say whatever the answer is, let's say the answer is some very big number, basically max of ARR, right? So it's the maximum number in the ARR, let's say. So the answer that you'll check is, you'll basically say answer is equal to minimum of the answer and the sum, whatever is the sum you get. Obviously the answer has to be greater than 0, greater than equal to 0, right? So if sum greater than equal to 0, then do this, right? In which case, do take the answer. So if the sum is greater than or equal to 0, then take this. Otherwise, you don't take it because it could just become a negative number, which is not allowed to us, right? We can only take a positive number at that point. So this is one case. This is the backtracking solution in the sense that for each number, I either take it or subtract it or don't take it at all, right? This will be huge because it is actually going to be like, I guess 3 raised to n, right? It's going to be like a 3 raised to n approach here. It's exponential. It's just going to like kill you, right? Especially n is 100, so it's going to be like 3 raised to 100. It's not happening, right? Or even a 2 raised to 100 is just not going to help you out. So that's not going to work out, right? But I'm just telling you that this is possible. In some cases, like C++ might even help you out here. So you might still be able to pass this with C++ in some cases, but again, I would not bank on it. Don't bank on that. The other approach is to think of it even in a different way. Okay. So now let's say, for example, the particles are A, B, C, D, E. Okay. The final solution that you get, the final solution after all of the particle simulation and so on that we get over here, what's it going to be? It's going to be a combination of these numbers, right? It is going to be, let's say I did A minus B, and then I did C minus D. Okay. And then what did I do? I did like, okay, this particle minus this particular particle, C minus D, let's say. A minus B minus some C minus D I did. Okay. Let's say that is the answer. If I expand this further, what do I get? I get A plus D minus B plus C. Correct? This is what I end up getting, everybody. A plus D minus B plus C. Yeah. Are you guys clear so far over here? So my minimum number, so what I'm saying is, let's say this is my answer, right? The min particle that I can get. Okay. And over here also, I say that this is still my min particle. Correct? Now, going further over here, and going further over here, this is just with 5 elements, right? Let's say I could have had multiple elements, right? I could have like F, G, H, I. And what I'll finally get over there in that also cases, I will get like, some numbers with a plus sign, some numbers with a minus sign. I'll get A minus B plus C plus D minus F. Maybe G is not included only. Maybe H is not included. Let's say minus I. I will always be able to make it into 2 distinct groups or camps, right? I will be able to make it like A plus B plus, let's say C plus D minus F plus I. Right? Does that make sense, everybody? I will always be able to say that in the final form, whatever minimum particle I get, that minimum particle is a difference of 2 subset sums. My minimum particle is a difference of 2 subset sums. Correct? Since I want the minimum particle, what do I do? Because I want the minimum particle, I want to minimize the difference of these 2 subset sums. Right? How many subset sums are possible? There are many. There are up to sum of this entire array subset sums possible. Right? So I'm not saying that how many are possible or not, but I'm saying of all of the subset sums possible, we want to find the minimum difference of any 2 subset sums. We want to find the minimum difference of any 2 subset sums. Does that make sense, everyone? Right? Everyone who's online anyways. Right? Okay. Cool. There are still people online. Awesome. So, and that's it. So we know how to find the subset sums. We know what are all the possible ways. Now, this is another thing. If a subset sum can be reached 2 times, then the minimum sum is 0 only. if there are two ways of reaching a subset sum, then we know that we can take one subset like this, one subset like this, and just make it 0, right? But if a subset sum does not occur twice, then we just take the minimum subset, the difference between the minimum subset sums. The minimum difference between any two subset sums. Does that make sense, everyone? Can you repeat? Okay, sure. Let's take an example. Okay. Let's take the example of the one we had earlier, right? Not this one. Oops, I lost the example, is it? Does anybody remember the example? One second. Yeah, I have the example. Okay, let's look at this example, which is, okay, what are all the subsets possible in this? What are all of the possible subsets that you have in this? You will have 2 raised to 4, which is about 16 subsets possible, right? You're going to have 30 itself. So let me just actually remove one of them just to make it easier. Now, how many subsets will you have possible? You're going to have possible 8 subsets, right? Which are 30, 75, 101. Then you could have like 30, 75, 30, 101, 75, 101, and then all of them together, right? Which would be, if I look at the sums, what are all the possible sums? Possible sums are 30, 75, 101, 105, 131, 176, and if I take this, all the sums together, it will be sorry, I'm blanking out. 206, right? That would be the final thing, right? Yeah, yeah, correct. 206. Okay, so these are all of the possible sums. Now, what we are saying is, if we find the minimum possible difference between any two subset sum, that will give us the minimum particle possible. Okay. So mathematically we proved that, but just trying to say, see, if these are our subset sums, what is the minimum difference between any two subset sums? What is the minimum difference between any two subset sums over here? So for 30, the minimum difference will be with 75, so you'll get 45. For 75, minimum difference will be with 101 only, so you'll get 26, right? 101, you'll actually get 4. So between 101 and 105, you'll get 4. Yeah, and that gives us the answer actually. 105 to 131 will give us 105 to 131 will give us 26. 131 to 176 will give me 25. 25. No, 45. Right, and 176 to 276 will give me 30. Right, so these are all the differences possible. The minimum difference possible is 4 for us. Right, so the answer is 4. And how is the answer 4? You will combine 101 minus 75 to give you 26. Then you'll do 30 minus 26 to give you 4. That's what you're going to do. So in mathematical form, what we did was, we did something like, we said 101 minus 75. This particle will be subtracted by 30 is what we're going to do. What we essentially did was, we said 30 plus 75, this subset sum, minus 101, this subset sum. That's what we have done. Does that make sense? Right? So getting all the possible subset sums, you guys know, right? And let's just take the other example just to show you all, right, about this. That let's say, for example, I had, Let's add something like this. Okay. So let's say I had something like this over here, right? Now, obviously, there's going to be like a lot of subsets here. So I'm not going to get into all the subsets because it'll be 2 raised to 4. 16 subsets is what I'll end up getting over here. But what I want to show you is I will see 5 as a subset sum will come only once. Okay. 15 as a subset sum will come 2 times. 15 as a subset sum comes 2 times. 15 itself and 10 plus 5, 15. Correct, everyone? Meaning that the minimum particle I will get over here is 0. Because one of the 15 subset sums can collide with the other one and give us 0. What do I mean by that? If you had something like 15 minus 10 minus 5, which is basically 15 minus 10 plus 5. So the minimum particle I'll get is 0. So if I get a subset sum which is occurring more than once, I know for sure that I'll get a minimum particle which is 0 only. But if I get a subset sum which is not, if I don't have any subset sum which occurs twice, then I take any 2 consecutive subset sums and see which has the minimum difference. Does the logic make sense now? Particle simulation, right? So subset sums, you guys know the DP part, how to generate it. Does everybody know how to generate the DP part of subset sums? Right? Simply just get the subset sums, figure out the minimum difference, and that's your answer. Clear, everyone? No, don't know. Is there any tutorial to learn? Okay, I'll just quickly show you. Yeah, because for some people it's not done. I'll quickly show you what that looks like. I had a feeling. Okay, this is how the subset sum works, by the way. I'll just show you. Because tomorrow is the test, you will not have another time to learn it. So, okay, imagine this is the array. Okay, imagine this is the array. This is 2, 3, 4, 5. Okay, this is the array given to you. First things first is sort the array. First things first, make sure you've sorted the array. Okay, what you will do is you will create a 2D array over here. And what exactly the 2D array is doing? The 2D array's columns tell you, is it possible to reach that particular sum or not? So see, this 2, 3, 4, 5 is there. What does it mean? It means that at max, you can have a subset sum of the entire array. At max, 2 plus 3 is 5, 5 plus 4 is 9, 9 plus 5 is 14. So at max, you'll have, yeah, it's like knapsack, absolutely correct. But so you'll have maximum sum that you can get as a subset sum is 14. Correct? Did you get that? So maximum I could get is 14. So I say that, okay, I'm going to try from 1 all the way up to 14. What are all of the subset sums that is possible to reach? I know 14 is possible to reach because that's the sum of the array. But in between from 1 to 14, which are all possible to reach? The way I'm going to do it is I'm going to say, okay, if and only if I had 2, nothing else, I had just 2. If I had only 2, what are all the possible ones to reach? So if I had only 2, the possible ones to reach would be, I could reach 1. There is one way of reaching that. I could reach here. Could I reach 3, 4, 5, 6, 7, 8, 9, 10? No, I can't reach any of them. I can only reach 2. I can't reach anything else. Okay. Because on its own, 2 can only do this. Fair enough. Right. So I did this and that's it. Okay. 1 can't even be reached. Now for 3, when I have 3, what I'm saying is, it means that I calculated for 2 what are all the ones to reach. For 3, I'm saying, as 3, I can help you out to reach some more subset sums. That is what I'm saying. So I say, okay, earlier it was possible to reach this anyways. So let that be continued, because I'm saying that it's not just with 3. I'm saying now 2 and 3 both are involved. So earlier it was just 2 involved. It could reach just 2 and nothing else. With both 2 and 3, we can anyways reach what all 2 could reach, which was basically 1, there is no way, 2, there is a way. And now I can probably add further. So 3 earlier was there anyway? No. Okay. But now I have another way with me, right? I have another way that you can actually reach it. So this 3 adds on its own. Can I reach 4? Well, with 3, you cannot reach 4, but maybe 3 can help the previous one reach 4. How can it help? If previously 1 was possible, then 3 can make 4 possible, because all of the ways it was possible to reach 1 can now come to 4 because 3 is enabling it. But there is no way. Earlier there was 0 ways. So 3 does not enable further. It continues to be 0. Okay. All right. Was it possible to reach 2 earlier? Yes. So now it will be possible to reach 5 also. All of the ways it was possible to reach 2, now I can reach 5. So I get 1 over here. 6, was it possible to reach 3 earlier? No. So 6 also is not possible to reach right now. 7, 8, all of these continue to remain the same. Now let's come to 4. For 4, up until 4, I have no change. It continues to be as is. So up until 4, it's the same thing, right? I continue to be as is. When I come to 4, yes, there is a way of reaching 4 now because of this. What about 5? Well, if there was a way of reaching 1 earlier, then I can make you help come to 5, but no, I can't. 6, was there a way of reaching 2 earlier? Yes, there was. I can make that come over here. So it becomes 6. Was there a way of reaching 7 earlier? Yes, there was. So I can make that come here, become 7. 8, was there a way of reaching 4 earlier? No. 9, was there a way of reaching 5 earlier? Yes. So I can make you come further. So it becomes this. For 10, there was no way of reaching 6, 11, no way of reaching 7, and so on, all the way till 14. Right? Okay, cool. Now when we come to 5, up until 5, that is 0 to 4, it remains the same. I don't do anything else. From 0 to 4, it will remain the same. When it comes to actually 5, one second, did we miss out something? Oh, sorry, this has to continue as is earlier. Well, there was a way of reaching 5, so it will continue to be here, right? 4 does not add a way, but how many ever ways were there of reaching 5, it will continue to be. So this 5 continues here, by the way. So this comes from previously. Okay, right. Now, what did we say? Said that, okay, up until 5, it's fine. With 5, I am myself adding a way of reaching 5. And there was earlier one way of reaching 5 anyways. So actually speaking, now there are 2 ways of reaching 5. Not just one way, there are 2 ways of reaching 5. Because earlier there was one way anyways. I am saying now there's another way of reaching 5. So there are 2 ways. What about 6? Earlier there was one way. Does 5 have another way to add? No. So 6 as is comes here. 7, earlier there was one way. Does 5 add another way? Yes, there was earlier a way of reaching 2 also. So 5 plus whatever way of reaching 2 was there could be helped. And anyways, I could reach 7 earlier. So there are 2 ways of reaching 7. So there are 2 ways of reaching subset of 7. And look at that. 2 plus 5, 7 and 3 plus 4, 7. So there are 2 ways of reaching it. Earlier, there was no way of reaching 8. Can I reach 8 now? Well, if there was a way of reaching 3 earlier, then this 5 can extend it. And yes, there was a way. So now it becomes like one way. 9, there was one way of reaching 9 earlier. If I can help up another, if there 4 was there, I can help it reach another way. So there are 2 ways of reaching 9. How are there 2 ways of reaching, right? 4 plus 5, 9, and 2 plus 3 plus 4, 9. So there are 2 ways of reaching 9 over here. 10, was there a way of reaching 5 earlier? Yes, there was. So now I can help you reach in one more way. Was there a way of reaching 6 earlier? Yes, there was. So I can help you reach. 7 earlier? Yes, there was. 8, there was no way of reaching. And 9, was there a way of reaching? Yes. So I can reach 14 also. Okay. So this way, if I check the last row now, what does the last row tell me? The last row tells me that if I have 2, 3, 4, and 5, all of these candidates I have, then I can tell you how many ways are there of reaching each subset sum. So for a subset sum of 1, there are 0 ways. Subset sum of 2, there is 1 way of reaching. For 3, there is 1 way of reaching. For 4, there is 1 way. 5, there are 2 ways of making the subset sum. 6, there are 1 way of creating. 7, there are 2 ways, and so on. So basically, this tells us the number of ways in which I can reach each subset sum. If this was our array, coming back to particle simulation, if this was our array, what it would mean is the minimum particle I'd get is 0 because there are 2 ways of reaching a particular subset sum. In this case, the particular subset sum is 5 or even 7 or even 9, right? So there are 2 ways of reaching a particular subset sum over here. That's how subset sum works. You can check out, it's a very popular thing. You'll find a bunch of tutorials online. So you can just check that out. And once you create that subset sum, you can get the consecutive subset sums from that, right? Does that make sense to you? The person who asked to repeat, or person who asked not to repeat, to just like have a tutorial on that. Clear? Is this one? Okay, super. All right, so that is this one. Please go ahead and implement it. I'll upload both the Python and Java solution also in the hint, so you guys can practice that. So we'll upload that one. Lastly speaking, about the strong primes, right? So you guys wanted to know how to do the strong primes. So if I just talk about strong primes, right? Should we just discuss strong primes once, everybody, and then that will be the last thing for today? Does that make sense, everybody? Shall we do strong primes now? Are you guys tired? Okay, you're still up for it. Till you guys are up for it, I am still up for it. Okay, so strong primes works like this. This is the question. Strong prime. You're given Q queries, and each query there are two numbers L and R. You have to calculate the number of strong primes present in the range L and R inclusive. A strong prime is a prime number that is greater than the arithmetic mean of the nearest prime number above and below. Algebraically, a prime P is said to be strong if. So basically, if you take the previous prime and the next prime, and the average of that, or rather, basically this. So let's take 2, 3, and 5. These are prime numbers. Is 3 a strong number? Well, 3 into 2 is 6, and 2 plus 5 is 7. So 6 is not greater than 2 plus 5, 7. Hence, we can't say that it's a strong prime. 3 is not a strong prime, right? So what it's basically telling you is that I will give you some ranges, and you have to figure out the number of strong primes between them. So how would I figure out the number of strong primes between them? Let's just take a simple example over here. Right? Let's say I'm given something like this. There are 3 queries, and then these are the ranges given. So basically, if I take the range 10 to 20, what are all the prime numbers there? I have the prime numbers 11, 13, 15, 11, 13, 17, and 19. These are the prime numbers. I don't have any other prime numbers. Is 11 a strong prime? To find out if 11 is a strong prime, I need to know the previous prime number also. What is the previous prime number? 7. So ideally, I need to take 11, 13, 17, 19, and I need to take the next prime number also, so that I'm able to tell whether 19 is a strong prime or not. Okay, cool. So is 11 a strong prime? Well, 2 into 11, if I just look at it like this, can you guys quickly tell me, is 11 a strong prime? Okay, 2 into 11 is equal to 22, and you have 7 plus 13, which is equal to 20. So is 2 into 11 greater than 7 plus 13? Is it? Yes, it is. Then 11 is a strong prime. So this is good to go. This is a strong prime. Bad color, but you get it. This is a strong prime. Okay, so that is one strong prime. 11, very bad color. Okay, I'll just underline it. 11 is a strong prime. What about 13? 2 into 13, 26. 26 is not greater than 11 plus 17, 28. So it's not a strong prime. 17, 2 into 17, 34. Is it greater than 13 plus 19, which is 32? Yes, it is. So 17 is a strong prime. Okay, 11 is a strong prime. 17 is a strong prime. What about 19? 19 is 2 into 19, 38. And 17 plus 23 is 40. So 19 is not a strong prime. So I have 2 strong primes between 10 and 20. Okay, I have 2 strong primes between 10 and 20. That's the question. For every given query, I need to figure out all of the strong primes between those 2 numbers. Okay. Is that clear? Question is clear, right? Okay. Let's quickly look at what are the possible approaches. So let's look at the approaches here. What are the approaches? Well, one of the simple things you can do is go from L to R for every query. So for each query, go from L to R, and when I go from L to R, check if it's prime, check if it's strong prime, count plus plus, right? This is what I'll do. Yeah. Needless to say, this is going to be huge. Like it's going to cost us a lot, especially I don't think the constraints are given. Oh, constraints are given in the question. So if I get the constraints of the question, it goes like 10 raised to 5 queries, and L to R could be 10 raised to 6. So it's easily for each query, I'm going to go from L to R. So there itself, 10 raised to 5 into 10 raised to 6, 10 raised to 11, I'm gone there itself. And going from L to R, figuring out if it's a prime number, if I'm doing order square root n, I've gone over there. So I can't really do much over there. So fairly clear over here that this is not going to be efficient enough, right? Everybody, this makes sense, right? Okay. What are some better ways how we could make it better? Everybody, how could we make this better? Okay, make strong prime count array number of strong prime till that number. Okay, somebody's saying, okay, yeah, I think that's pretty much it. So what you need to do is, first of all, pre-compute all the strong primes from min L to max R. Yeah. What I'll do is from 10 to 50, I'll find all the strong primes. I'll find out all of the strong primes from 10 to 50. So because I'm taking all the queries, I don't need to give the answer for every query. Let's take up all the queries. Let's store the queries. So 10, 20, 20, 30, 30, 50. Let me just store this somewhere. Between 10 to 50, let me take out all of the strong primes. Let me figure out, even before that, just let me figure out the primes, which is again not too difficult. And yeah, or rather, better way to put it is pre-compute all the primes. Let me just forget the strong primes. All the primes from, technically you'll need to pre-compute from 2 to max R, because to compute the other primes, you will need to anyways know the prime numbers below that. Like you will not be able to find if, let's say 91 is a prime number or not, if you don't pre-compute 2, 3, 5, 7, you will need all of those prime numbers, right? So pre-compute all the prime numbers from 2 to max R, not min L from max R, but 2 to max R, right? Once you've done that, then pre-compute all the strong primes from min L to max R. Do that. And for each query, just refer to the prefix sum array. That's all you need to do. It's easier said than done. Let me just show you what I mean by this. For example, we were here, I guess. Second. No, this was some other thing. Anyway, so we were here, right? So let me just talk about, for example, let me just say you are talking from, index number 2 to, let's say 0, 1, 2, all the way up until 20. Let's say 10. Yeah, let's take it like that. Okay. And the idea here is, what we are going to count is how many prime numbers are there from here till here. Okay. And we'll further have a cumulative sum array counting the number of prime numbers I found so far. So then I can, within the range, find out how many prime numbers are there. So 1 second. All right, cool. So 0 is not a prime number. I have 0 prime numbers. This is not a prime number. 2 is not a prime number. Sorry, 2 is a prime number. 3 is a prime number. 4 is not a prime number. 5 is a prime number. 6 is not a prime number. 7 is, 8 is not, 9 is not, 10 is not, 11 is, right? 12 is not, 13 is, 14 is not, 15 is not, 16 is not a prime number, 17 is a prime number, 18 is not a prime number, 19 is a prime number, and then 20, 21, 22, none of these are prime numbers, right? What we'll do is we'll create a cumulative sum of all of the prime numbers so far. Okay. And you guys should ideally, you guys all know how to do the cumulative sum, right? So 1 second. It's 0, 0, 1, 2, meaning that up until 3, I found 2 prime numbers over here. Okay, then till 4 I have found 2 prime numbers. Till 5 I have found 3 prime numbers. This is continues to be 3. Then this becomes 4. Till 7 I found 4 prime numbers. 4, 4, 4 becomes 5. 5 becomes 6. 6, 6, 6 becomes 7 prime numbers. 7 becomes 8th prime number. 8, 8, 8. So up till 22, I have 8 prime numbers is what we are saying. Now, my question is not to find the number of prime numbers between any two ranges. The question is to find the number of strong primes. So actually, once you have found all of the prime numbers, figure out if that's a strong prime or not. Okay, figure out if it's a strong prime or not. And that is also pretty simple to do. The way you are going to do that is, if I talk about strong primes, 2 is a prime number. I don't bother with that. Simply put, you should take the next prime number and the previous prime number. You should always. So when I'm at 5, I will be able to tell whether 3 is a strong prime or not. Right? When I'm at 7, I will be able to tell if 5 is a strong prime or not. So I can always tell for the previous prime number and the previous to previous prime number. So what I'll end up doing is, I've created this subarray. When I come to 3, I will have, when I come to 5, I will have the last 2 prime numbers always stored with me. There were 2 and 3. So now I can go to 3 and update whether it's a strong prime or not. So 2 into 3, 6 is not a strong prime. So 2 is definitely not a strong prime. 3 is not a strong prime. 5, is it a strong prime? When I come to 7, I can basically tell. So 7 plus 3 is 10 and 2 into 5 is 10. It should be greater than, so not a strong prime, right? So like this, you figure out whether it's a strong prime or not. Every prime number, you figure out whether it's a strong prime or not. Once you figured out if it's a strong prime or not, create a cumulative sum for the strong primes. We created one for the primes, but actually you should create one for the strong primes. Then all you need to do is, between any two indexes, whenever it's given, just check how many strong primes were there up until a certain index. So all you'll do is, so anyways, what I was trying to say was, you create a strong, so basically for any query LR, for any query then, right? So for any particular query, what you'll end up doing is strong primes, because you pre-computed, right, the number of strong primes. So you just do strong primes R minus strong primes L minus 1. This is what you'll end up doing, right? Because all of the strong primes lesser than that would be before L minus 1, I will basically not use them anymore, and I'll go for strong primes up until this thing. I'll go from L to R basically, right? Is this clear, everybody? Are you guys understanding how this this one works out? Clear? Okay. Any last things that you guys want to know? Any last particular questions or anything that you guys want to know? I think it's went on a really long time. So any last stuff that you guys want to check out? If it's all clear, then do let me know. Yeah, I think I'm back. Right. So somebody had some doubts. Let me just check. Everything clear. Thank you so much. Okay, all clear. So what if for every R value, what if for each R value increases up to where we have to pre-compute? You have to pre-compute till the maximum R. See, here we have till 10 to 50, right? So you go up until 50. That's it. And compute the number of strong primes up to 50. That's all you do, because you know there is not going to be any R greater than this, right? So first take input all of the L2Rs and then generate the primes and the strong primes and so on. Do check out the solution. There's already a Python solution on this. We're uploading the Java solution in a bit as well. Do check out the solution. You'll understand the logic behind it and how it's working. And the major thing to tell you all was, how did we even generate all the primes? We generated the primes by the sieve. Like I'm assuming you guys already understood that. So we generated it using the sieve of Eratosthenes, the primes. And that's where we reduced the time complexity a lot by generating by the sieve of Eratosthenes, right? Okay. Cool, everybody. So finally, just want to tell everybody again, if you had to practice a few things. So right now is, firstly, I just want to tell you a little bit about the time management strategy. This is what I told earlier. Looking at the level of questions, I highly suggest everybody to spend 20 to 40 minutes on the easiest question, whichever easiest question you can get. And trust me, there will be one question which is just simply an array is like sorted array, 2 pointers, that kind of a question, right? So 20 to 40 minutes spent on the easiest question. Remaining 2.5 hours spent on the medium question. Don't even go for the difficult question, right? Spend remaining, because if you get 2 questions correct, then there's a very like there's a 99% chance you're getting called for the interview next, right? So don't try to figure out that, oh, let me do both those questions or something like that. No, let me just remaining time, let me just spend on the medium question. That's it. Try to get 100% test cases, clear all the edge cases, clear everything. Better to have 2 questions fully done than 3 questions half done. That's my thing to you. Somebody saying, so is there a fixed pattern? Like one question from graph, one from DP. See, DP and arrays, take a sure shot, it's going to come. DP and arrays, especially arrays, one type of a question, subset or 2 pointers or something, that is going to come. And DP, you can take that, it's going to come. Remaining could be trees, graphs, whatever is the case. But spend your time trying to do the DP and arrays question or maps question, right? Actually, I have not done graphs too. I am a little scared. Don't worry. Just revise the basic stuff of graph. Anyways, if they ask a very difficult question on graphs, there was no use of preparing for graphs also, right? So graphs is likely to be in the difficult one. I'd say don't worry too much, right? Everyone is saying 2 graph questions. So see, the questions we checked right now, there were no 2 graph questions. You guys have done graphs on DSA, so please go and revise those graphs, right? So that's already been done. Sorry, bit manipulation. Bit manipulation can also come. And for that, questions like special set bits is a good one to solve. Again, the solution is there already on the platform, so do check it out. But that kind of a bit manipulation can come, right? Okay, so this is the first thing on time management strategy. Second thing is, please, just one thing that I realized in the thing is, even the DP question that we discussed, make sure you know how to use inbuilt maps / dictionaries, which you guys know, lists, array list, which I guess again you should all know, and heaps as well. Please go ahead and figure this out in your own language. Like in Python, a priority queue is there, in heaps, in Java, and all of these. All of these have a built-in. Don't go out there and figure out how to develop a max heap, right? So don't go ahead and try to figure out a max heap on your own over there, but rather use the heaps that's actually there in the language. And that could be different for your own, like C++, Java, Python, whatever, but use the one that's already given. So just revise this part also. It could come very much in use tomorrow. Hi, sir. I'm selected for Infosys for Power Programmer role. Thank you. Hey, Ritik. Yeah, Ritik is a last year student. Thanks a lot for dropping in, Ritik. Please do wish these guys all the best. Ritik was just like you guys. So he's on YouTube right now. Ritik was just like you guys, very scared at the last moment whether I'll get in or not get in and so on. But if you've done your practice, you end up getting in. So thanks a lot, Ritik, for your kind words. Hope you're doing good in Infosys. I think you're joining this year, right? But yeah, all the best for Infosys, man. So glad to hear that you've joined, you got selected. Okay. All right, everybody, that's pretty much it. All the best to all of you guys. Thanks all for sticking till the end. It's been it's roughly about 3 hours now. So thanks a lot for sticking to the end. What is JP Morgan level? JP Morgan is a bit easier than HackWithInfy, actually. Also, again, arrays and DP is what they focus on. So arrays and DP, huge focus on that. Is what they like to do. Yeah. Okay. Is this the last class for HackWithInfy? Yes, but Code Vita is coming up. So, I think next week we'll have some Code Vita classes, or the week after that. So yeah, see you guys then. And if you guys have any classes coming up in your college, if you're associated with your college, then we'll continue with some stuff. Otherwise, if you are just joined up for the HackWithInfy prep pack, this is it. Hope you had a good time, and see you guys soon for Code Vita. That's it, everybody. Thank you all for joining today. Hope you've had a good time today. And yeah, I'll see you all next time. Those of you on YouTube, do hit the like button, please, and let us know in the comments what you liked, what you didn't like. Any solutions to the first question that you're discussing would be great. I'll also try to release a solution for that shortly as well. All right. Thanks everyone for joining today, and I'll catch you all next time.